Hey, first graders, it is a new week, and today is lesson 5 in mission 1. Okay, by now you've got the hang of it in Zearn. We have a classroom lesson where this video takes place of the classroom lesson. And if you were in the classroom, we call it a small group lesson. And then you have your digital lesson. That's where you go to the Zearn website, you log in, and you do the lesson that matches the classroom lesson. For example, we're doing lesson 5 today. You would go do lesson 5 for your digital lesson. And just a happy little tidbit, the brain is like a muscle. When I exercise it, it gets stronger. So when we're doing math, your brain is getting stronger because you're exercising it. Here are our virtual learning norms. These are some guidelines to improve the quality of your virtual learning experience. You want to make sure your device is charged or plugged in. Find a place that's quiet with little distraction. Have some writing tools. Always check for exit tickets following a lesson and do your best. And please ask for help. There's contact information for me and the other teachers. Contact us if you need some help. If you need help at home with material, ask an older brother or sister, ask a parent or a grandparent, but make sure that you're doing the work, because when you're doing the work, your brain is exercising and getting stronger. The classroom lesson is divided into 5 sections. I'm sure you're getting the hang of it by now. Fluency, word problem, concept development, debrief, and your exit ticket. Okay, here we go. Grade 1, Mission 1, Lesson 5. Just a reminder, the templates included in this lesson are attached in Google Classroom. Here is today's objective. I can represent put together situations with number bonds. That just simply means I can represent made up stories with number bonds. And that's pretty simple. We can do that. The second part of the objective is I can count on from one embedded number or part to totals of 6 and 7 and generate all addition expressions for each total. And that just simply means I can find the parts to get to the totals of 6 and 7, and I can make the addition expressions to get there. And expressions are just simply 1 plus 1, 1 plus 2, 1 plus 3. Here's our fluency exercise. It is called Shake Those Discs 6. This seems to be a favorite among students. We have sets of partners. One is a shaker and one is a recorder. And if you're in the classroom, we use what is called counters. It's just a little circle piece of paper that is yellow on one side and red on the other. But because I was not in the classroom, I chose something that was around the house. And you are probably at the house, so go grab some pennies. You'll need 6 pennies. And pennies, as you know, have 2 sides, heads and tails. And so here is a demonstration of how you play Shake Those Discs 6. Okay, this is how you play Shake Those Discs 6. We're going to take turns. You're going to be the shaker, I'll be the recorder, and then I'll be the shaker, and you be the recorder. And we're recording how those pennies land. So go ahead and shake them and toss them out. How did they land? What parts do you see, James?
I see 5 heads and 1 tail.
Okay, so which column do you think I need to put the X in? Right, so I'm going to put an X at the very top. Now we're going to switch. You're going to be the recorder, And I'm going to be the taker. How did they land? What do you see?
4 heads and 2 tails.
Okay, which column would you put the X in?
This one.
Okay. And that's how you play Shake Those Discs 6. Moving on to our word problem. Notice the hand with the pencil reminds you to get some writing tools. Notice the cloud with the RDW. What do those letters stand for? Read, draw, write. You are so smart. You got it. So first we're going to read this word problem. Marcus had 6 pieces of candy. He decided to give some to his mother and keep some for himself. Use pictures and numbers to show 2 ways that Marcus could have split up 6 pieces of his candy. Did you hear any numbers in that word problem? Right, I heard the number 6 twice because Marcus has 6 pieces of candy. Also, we hear 2, but I don't think 2 is something we need to be adding because listen to that sentence. It says, use pictures and numbers to show 2 ways. Does that mean that we're going to be adding 2? I think 2 is just describing the ways that we need to show how Marcus split up those 2 pieces of candy. They're wanting us to show 2 different ways. So that is just a description. That doesn't need to be in an equation with our word problem. Do you hear any key words that tell us that we're going to be adding? I didn't hear any of our key words. I didn't hear the word more or altogether. So we're probably not going to be adding in this problem, but there's still an important word that we need to focus on, and that word is some. Some doesn't tell us exactly what number we're working with. Some is kind of a mystery. And I think in this word problem, they're letting us decide what those numbers can be. We're splitting the candy between Marcus and his mom. Finally, do you know what we're working with? What are our units? Right, we're working with pieces of candy. That's our units. So we're going to highlight all of those things to help us remember. And the first thing we're going to do is draw those pieces of candy that Marcus has. I'm going to show you the first way I chose to split the candy between Marcus and his mom. I believe in being fair, so I chose the parts 3 and 3. The total is 6. I chose for Marcus to have 3 pieces of candy, and I chose for Mom to have 3 pieces of candy. So the last thing would be to make a statement. Marcus can keep 3 and give his mom 3 pieces of candy. Okay, that is one way you could split these candy pieces. But the word problem is asking us to show another way. Here's the second way I chose to split. I chose to split it into the parts Marcus has 5 and Mom has 1. And here's my number bond. 6 is the total, Marcus has 5, and Mom has 1. And so the final thing for this way is to show a statement. Marcus can keep 5 and give his mom 1 piece of candy. So now I've shown 2 ways that the candy was split, but you might not have chosen those 2 ways. You might have chosen another way. So I'm going to show you maybe what you chose to do. You might have chosen to give Marcus 4 and Mom 2. Those are also parts of 6, so that's also correct. And that statement is Marcus can keep 4 and give his mom 2 pieces of candy. You might have chosen a different way. There's another way that you could have split that candy between Marcus and his mom. What about this way? Marcus kept all 6 of those pieces of candy, and Mom has 0. That's right. That's not a very nice way to do it, but it is a way. So 6 is the total. Marcus has 6 and Mom has 0. And the statement is Marcus can keep 6 and give his mom 0 pieces of candy. So hopefully you chose one of those ways, or actually 2 of those ways, to split that candy between Marcus and his mom. Just a review, here are our key words for addition. We've used the words more, in all, and all together. Are you ready for a brain break? Here we go. Three, two, one. And we are ready to learn. Before we get to the concept development, I feel like it was important to explain what are 5 group cards, because we talk about them during lesson 5. They are math tools to help students practice and learn the counting on strategy. And we will attach these templates. You'll find them in Google Classroom. They are not mandatory, but it is very helpful to have them handy. Here is our concept development. Look at those students. How many students are here? That's right, there is a total of 7 students. What does the 7 represent in the number bond? The 7 represents the number of students, or the total of students. There's one student that has something different from the rest. Do you know what it is? This student has a basketball. So we put the 1 in the part to represent the one student with the basketball. We also placed our 5 group card with the 1 dot under that. If one student has a basketball, what about the rest of the students? They do not have a basketball. There are 6 students that do not have a basketball. And there is our 5 group card showing 6. So here we have the parts of 7 are 1 and 6. Using 5 group cards, what's the best strategy to find how many students there are all together? We could count on from 1. Point with me to keep track as we count on from 1. So here's 1, 2, 3, 4, 5, 6, 7. Here's another way to count on. You flip the 1 dot card over and you show the number 1. Let's count on again. 1, 2, 3, 4, 5, 6, 7. What are the 2 parts that make 7? Right, 1 and 6. Say the number sentence that makes 7. 1 plus 6 equals 7. So we're going to say the number sentence starting with the student with the basketball. 1 plus 6 equals 7. We're going to say the number sentence starting with the students with no basketball. There are 6 students with no basketball. 6 plus 1 equals 7. Say the number sentence starting with the total. 7 equals 1 plus 6. And then finally, we're going to say the number sentence starting with the total, but flip the parts this time. 7 equals 6 plus 1. Let's try again. There are 2 students that have something different from the rest. Do you know what it is? Two students are sitting down. So we're going to write the 2 in the first part, and we're going to label it with the word sitting. And we're also going to put our 5 group card. If 2 students are sitting, what are the rest doing? They are standing. So now we're going to find the part of the students that are standing. And put our 5 group card. So we figured out that 2 and 5 are parts that make 7. Using 5 group cards, what's the best strategy to find how many students there are all together? We could count on from 2. Point with me to keep track as we count from 2. So here's 2, 3, 4, 5, 6, 7. Here's another way to count on. We could flip the 2 dot card to show the number 2. Let's count on again. 2, 3, 4, 5, 6, 7. What are the 2 parts that make 7? 2 and 5. Say the number sentence that makes 7. 2 plus 5 equals 7. Say the number sentence starting with the students that are sitting. Okay, there are 2 students sitting plus the 5 that are standing equals the total of 7. Say the number sentence starting with the students that are standing. Okay, there are 5 students standing, and we're going to add the 2 that are sitting. 5 plus 2 equals 7. Say the number sentence starting with the total. 7 equals 2 plus 5. Say the number sentence starting with the total, but flip the parts this time. 7 equals 5 plus 2. Let's try again. There are 3 students that are boys and there are 4 students that are girls. One part is 3 and we're going to label it boys. And there's our 5 group card. And the other part is 4 and we're going to label it girls. And there's our other 5 group card. Using 5 group cards, what's the best strategy to find how many students there are all together? We could count on from 3. Point with me to keep track as we count on from 3. 3, 4, 5, 6, 7. Here's another way to count on. Flip the 3 dot card to show the number 3. Let's count on again. 3, 4, 5, 6, 7. What are the 2 parts that make 7? 3 and 4. Say the number sentence that makes 7. 3 plus 4 equals 7. Say the number sentence starting with the boys. 3 plus 4 equals 7. Can you say the number sentence starting with the girls? 4 plus 3 equals 7. Say the number sentence starting with the total. 7 equals 3 plus 4. And then finally, we're going to say the number sentence starting with the total, but we're going to flip the parts this time. 7 equals 4 plus 3. One last time. How many students are smiling? Right, I see all 7 of them are smiling. They are happy. So there's our 5 group card. How many students are frowning? All right, I see 0. They're all smiling. So we're going to label that frowning. And there's our 5 group card to match. Say the number sentence starting with the smiling students. How many smiling students do you see? All right, 7 plus 0 equals 7. Say the number sentence starting with the frowning students. These are the students that are not happy. There's 0 of those, so 0 plus 7 equals 7. Say the number sentence starting with the total. 7 equals 7 plus 0. And finally, say the number sentence starting with the total, but flip the parts this time. 7 equals 0 plus 7. Woo, we're at the debrief. Look at the ways we made 7 in this poster. What patterns do you see? Let's revisit our poster for 6. What do you see is the same and different about our poster showing ways to make 6 and our poster showing ways to make 7? We're going to put those side by side so we can see them both. So both 6 and 7 have 4 columns here. They each have a part that's 1, but then look what happens to the second part. In 6 it's 5, but in 7 it's 6. Look at the parts here. They each have a part 2, but look at the other parts. 6 has 4 and 7 has 5. So math has all kinds of patterns. You're going to see that throughout your school career. You're going to see that math has a lot of patterns. Did we finish our objective today? I can represent made-up stories with number bonds. That's what those students were. We looked at who was sitting down and standing up and who were boys and girls and who had a basketball and who didn't have a basketball. That was all made-up stories. And we did number bonds for each of those situations. Did we count on from one embedded number or part to totals of 7 and generate all addition expressions for each total? I think we were successful today in completing our objective. Exit ticket. What did you get really good at today? You are doing a great job. You're exercising that brain, and I know it's getting stronger and bigger. Head on over and do your exit ticket.